Champs. Term Book. Class 4th. 3rd Term. Science. Chapter 4. Solids, Liquids and Gases. Solids. Introduction. What is a solid? To begin understanding matter, we must first define what makes a solid unique. A solid is one of the three fundamental states of matter, the others are liquid and gas. The defining characteristic of a solid is its fixed shape and fixed volume. Fixed shape. A solid does not change its shape based on the container it is in. A rock remains a rock whether it is on the floor or placed in a bowl. Fixed volume. The amount of space a solid takes up, its volume, does not change. How the particles behave, molecular arrangement. Why do solids act this way? The answer is found very small, at the molecular level. Everything is made of tiny particles, atoms and molecules. In a solid, these particles are packed together very tightly, usually in a highly organized, repeating pattern called a crystal lattice. Strong bonds. The particles are held together by strong forces of attraction. Because they are so crowded and strongly bonded, the particles cannot move past one another. They are locked in place. Vibrational motion. This doesn't mean they are completely still. The particles in a solid are constantly vibrating or shaking in their fixed positions, but they cannot travel to a new location. Properties of solids. Summary. Combining what we know about their shape, volume, and particle arrangement, we can summarize the main properties of solids. Definite shape. They do not conform to the shape of a container, image 1. Definite volume. They take up a specific amount of space that does not change. Incompressibility. Because the particles are already tightly packed, solids cannot be easily pressed into a smaller space. Rigidity. Solids are firm and resist bending or deformation. Extension for 4th grade. Many solids are crystalline, meaning their particles form beautiful, repeating geometric patterns, like salt or snowflakes, which we see visualized in image 2. Liquids. Introduction to liquids. What is a liquid? To start our lesson, we need to understand what makes a liquid special. A liquid is one of the three main states of matter, the others are solid and gas. The most important defining characteristic of a liquid is that it has a definite volume but no definite shape. Definite volume. This means that a specific amount of liquid, like 1 liter of water, always takes up the same amount of space. If you pour it from one container to another, the amount of space it occupies doesn't change. No definite shape. Unlike a solid, which holds its own shape, a liquid takes the shape of its container. It spreads out to fill the bottom of whatever you pour it into. How particles behave in a liquid. Why do liquids behave this way? To understand, we must look closely at what the tiny particles, molecules, are doing. Everything around us is made of particles. In a solid, like the ice we learned about, these particles are locked tightly together. In a liquid, the particles are still close together, but they are not locked in fixed positions. The particles in a liquid have enough energy to move around past one another. This movement is often described as sliding, flowing, or tumbling. Because the particles can slide past each other, the liquid can flow and change shape easily. However, they are still attracted to each other, which is why they stay together in a pool or a droplet rather than flying apart like a gas. Key property. Viscosity, thickness. Now that we know liquids flow, because their particles slide, we need to understand that not all liquids flow the same way. Viscosity is a scientific word for how thick or sticky a liquid is, or how easily it flows. It describes a liquid's resistance to flow. High viscosity. A liquid with high viscosity is thick and flows very slowly. It resists moving. Think of honey, ketchup, or peanut butter. The particles are bulky or sticky, making it hard for them to slide past each other. Low viscosity. A liquid with low viscosity is thin and flows very quickly. Think of water or juice. The particles slide past each other very easily. Gases. Introduction to gases. What is a gas? We have learned about solids, which hold their shape, and liquids, which take the shape of their container but keep their volume. Now, we come to the third state of matter, a gas. A gas is a state of matter that has no definite shape and no definite volume. No definite shape. A gas will spread out to fill the entire shape of whatever container it is in. If you let gas out of a small balloon, it immediately spreads out to fill the entire room. No definite volume. Gas particles don't stay together. They will expand or squeeze to fill the entire space available to them, whether that space is big or small. How particles behave in a gas. Why does gas behave this way? The answer is found deep inside the substance, at the particle level. Everything around us is made of tiny particles, atoms and molecules. Solids. Particles are packed tightly, vibrating in place. Liquids. Particles are close but can slide past one another. Gases. The particles in a gas are very far apart from each other. Because the particles have so much space between them, they have very little attraction to each other. This allows them to move extremely fast. They zip around randomly at high speeds. Independently, they travel in straight lines until they collide with each other or the walls of their container. These constant, high-speed collisions with the container walls, like the inside of the balloon, are what create gas pressure. Key property: compressibility, squishiness. Because the particles in a gas are so incredibly far apart, image 2, a unique property arises. Gases are highly compressible. Compressibility is the ability to be squeezed into a smaller space, volume. If you have a gas trapped inside a container, like a syringe, you can push the plunger down. When you push the plunger, you aren't squeezing the particles themselves. You are simply pushing the empty space between the particles closer together. Solids and liquids resist being compressed because their particles are already touching.